Hello, calculus students. Today we're going to be talking about particle motion, and College Board loves these questions. It's a point with no length, no width, just a single point moving in space. Also called rectilinear, rectangular, linear motion. So we're going to go through some examples. And then we'll talk about some definitions. So on Earth, if you shoot a paperclip straight up in the air with a rubber band, the paperclip will be at position S of t, and S is a common variable for position.
Good morning, Ms. Palmer. Please stand for the.
All right, thank you, student council. Above your hand, so this variable is used pretty commonly for position. So 64t minus 16t squared. So it's going to go up and then back down. So how long does it take the paperclip to reach its maximum height? Well, to do that, we're going to look at the derivative. Okay, the derivative of position is velocity. Okay, so we're going to take this derivative, which is going to be 64 minus 32t. Well, why would I want velocity? Well, if I'm looking for where it reaches its maximum height, that means it's going to go up and back down. That means the velocity is going to be 0 at that instant. So if I set this equation equal to 0, okay, subtract 64, divide by negative 32, we get t equals 2 seconds. Then we can use that to find the maximum height. So I'll take this and plug it into our position. So 64 times 2 minus 16 times 2 squared, which gives us 64 feet. So motion on a line. S of t is going to be the position at time t. Okay, v of t is the derivative of position, and it's going to be the velocity of the particle. At time t. So what information does the velocity provide about the motion? So if the velocity is greater than 0, meaning the velocity is positive, then we consider that the particle or whatever is moving to the right. If the velocity is less than 0, meaning negative, then our particle is moving to the left. R of t is the speed of the particle, which is going to be the absolute value of the velocity. Speed is always positive. Velocity is going to be the same number, but the sign associated with it also tells us direction. Acceleration is going to be the derivative of, or A of t is the derivative of velocity, which is going to be the acceleration. So how fast, or the rate of change of the velocity. Acceleration. So acceleration will be positive and negative as well. And if the particle is speeding up, the velocity and acceleration have this. So I'm just going to kind of visualize that. So if our velocity is positive and our acceleration is positive, that means it's going to be speeding up in the same direction. Same with positive. If I have negative velocity, it's going to go this direction. Negative acceleration, means it's going to be accelerating in that direction. So if velocity and acceleration are both positive, we're speeding up. If velocity and acceleration are both negative, we're speeding up. The opposite is true if they have opposite signs. So if you have positive velocity going this direction, but your acceleration is going in the opposite direction, you're going to be slowing down. And same with negative. If your velocity is negative, you're moving to the left, but the acceleration is positive, that means you're going to be slowing down. This whole next page, 3 through number 6, well, 3, that should be a 1, I think. 1 through 6 here is an exploration that feel free to go through. I'm not going to go through it here. It's just kind of a demonstration, but it's not really all that necessary to understand the content. But feel free to go through it. It's kind of a cool little visualization of all of this stuff. All right, so on the next page, describe the motion of the particle for 0 is less than t is less than 10. So that's usually an important information. If our position, f of t, is 2t cubed minus 21t squared plus 60t plus 3, s is in feet and t is in seconds. So we're going to find velocity and acceleration using derivatives. So v of t is going to be the first derivative of position. So that's going to be 6t squared minus 42t plus 60. Our acceleration is going to be the derivative of this, so 12t minus 42. So at t equals 1, we plug in 1 into our position, plug in 1 into our velocity, plug in 1 into acceleration. I'm certain you are capable of plugging in numbers. So s of t, when we plug it in here, is 44. V of t, when we plug it into this guy, gives us 24. And a of 1, plugging it into this, is going to give us a negative 30. So we're going to look at what information does that tell us. Okay, so the particle has moved to the point s equals, s of 1 is 44. So at 1 second, the position is at 44. The velocity is positive, which means the particle is moving to the right. And the acceleration is negative. So if velocity and acceleration have opposite signs, then the particle is slowing down. Okay, because it's moving to the right, but the acceleration is slowing it down. Okay, so let's graph velocity. Okay, so we're going to graph the velocity equation. So 6t, which we'll replace with x squared, minus 42t plus 60. Okay, as far as my graph is concerned, for my window, we just care about from 0 to 10, because those are our t values. For our y values, if I have a y-intercept of 60, that means I need a pretty big window. Another hint, another trick, is to use the table. Let me check my table set. I'm starting at 0, going by 1, perfect. Then if I go to my table, these are the numbers that I need to see. So from 0 to 10, my smallest number is negative 12. My biggest number is 240. So for my window, I'm going to go from, let's say, negative 20 on up to 250. Okay, so this is the velocity, and we're going to use this to answer some questions. Okay, it says at points t equals blank and t equals blank, the velocity is 0. So that's where the graph is going to cross the x-axis. So that's going to be at 2, and at 2, 3, 4, 5. Okay, that means the particle is 0, the particle is stopped at those points and may change directions. It can reach 0 and not change directions, but it may change directions. And we can tell that in this case it does, because velocity goes from positive to negative and then negative to positive, which means it's moving to the right, then it's moving to the left, then it's moving to the right. So now on top of this graph, we'll add the, oh no, squared minus 42t plus 60, don't delete yours. Okay, the acceleration, 12x minus 42. Okay, so if I graph that now, there's our velocity. And there's our acceleration. I'm gonna make my window a little bit lower there, so we can see the entirety of both graphs. Okay, and we'll answer some follow-up questions here. So at the point t equals blank, the acceleration is 0. So we're looking for this point here, and that's going to occur at 3.5 or 7 halves. So then we're going to compare velocity and acceleration and determine if the graph is slowing or speeding based on the sign, positive or negative, of each. So from 0 to 2, 0 to 2, this graph is going to be, or the particle is going to be slowing. Okay, because my velocity is positive, but my acceleration is negative. From 2 to 7.5, so here's 2 to 7.5, they're both negative. They're both below the x-axis, so it's going to be speeding up. From 7.5 to 5, my acceleration is above the x-axis, but my velocity is below, so it's going to be slowing. And then from after t equals 5, they're both positive again, so it's speeding up. So how far has the particle traveled from t equals 0 to t equals 5? So I want to know, this little particle, how long its journey has been. So I'm going to look back at the velocity. So it's moving to the right from 0 to 2. From 2 to 5, it's moving to the left. And from 5 to, oh, that's all we care, 0 to 5. So from 0, so I want to find the position at 0. I want to find the position at 2, and I want to find the position at 5. Because like I said, it's moving from 0 to 2, it's moving to the right. From 2 to 5, it's moving to the left. So I want to know those positions. So we're going to plug 0, 2, and 5 into our position equation. So from at 0, it's at 3. At 2, it's at 55, and at 5, it's at 28. So it goes from 3 all the way up to 55, and then it goes from 55 all the way back down to 28. So the distance traveled, I'm going to look at how far apart those are, which is 52, and how far apart those are, which is 27. So it moved 52 units to the right. It moved 27 units left, or feet, I guess in this case. So the total is going to be the sum of those. So the sum of 52 and 27 is 79 feet that this particle moved between 0 and 5. All right, back before you were born in 1987, this was an AP problem. It says the particle moves along the x-axis so that its acceleration is 6t minus 18. At time 0, the velocity is 24. At time 1, its position is 20. So the first thing we're going to do here is write an expression for its velocity. So remember, going in our derivatives, we start with position, take its derivative to get velocity, take its position to get acceleration. Well, we have acceleration, so we need to take the antiderivative to get the velocity. So the antiderivative of this, okay, is going to be 3t squared minus 18t plus c. Because when we take the derivative, the constant goes away. When we do the antiderivative, we have to add in a constant. But we have enough information to figure out what that constant is. So v of 0 is 24. So I'm going to set this equal to 24. And plug in 0. So that's 0, which means c is 24, which means my velocity equation is 3t squared minus 18t plus 24. For what values of t is the particle at rest? Which means we're going to set this equal to 0. This would have been a non-calculator question, which means we need to solve this analytically, meaning factoring. So first I'm going to factor out a 3. Which leaves me with a good old trinomial to factor. So this is going to be t minus 4 and t minus 2, which means the times that we are at rest are t equals 4 and t equals 2. To figure out what values the particle is moving to the right, I'm going to break this down, and we're going to use number lines, and we're going to start using number lines quite a bit. So I'm going to make a number line for t minus 4. I'm going to make a number line for t minus 2. I'm going to start at 0. On this line, I'm going to put 4. On this line, I'm going to put 2. And then I'm going to make a third line for velocity that has all of those numbers. Okay, so we're going to look at t minus 4. If I plug in a number less than 4, for example, 0, we're going to get a negative value here. If we plug in 4, we get 0. If I plug in a number bigger than 4, like 5, we're going to get a positive value. On this number line, if we plug in a number between 0 and 2, we'll get a negative. If we plug in 2, we get 0. And then any number bigger than that is going to be positive. Well, in my velocity equation, we're multiplying those two together. So if I multiply a negative times a negative, we're going to get a positive, which means our velocity is going to be positive there. It's going to be 0 at 2 and 4. Between 2 and 4, we're multiplying a negative number times a positive number, which means this is going to be negative. Positive times positive is positive. So that's how we can do the same analysis that we did graphically using the equation. You're just figuring out where is the parabola going to be above the x-axis and below the x-axis, just using the equation instead of the graph. So to answer the question, when is it moving to the right? It's going to be moving to the right when velocity is positive. So that's going to be between 0 and 2, and when t is greater than 4, because it's positive there, and we don't include the endpoints because at 2 and 4, it's neither increasing, or it's neither positive or negative, it's 0. To figure out where the the values where the particle is speeding up, we need to compare velocity and acceleration. Okay, so I'm going to make a number line for acceleration. and velocity, and there's different ways to do this. I just like the number lines. Okay, for acceleration, I'll just write the equation. Okay, is 6t minus 18, which means it is, I'm gonna put 0 here, 0 here. At 3, acceleration is 0. So for acceleration, I plug in a number less than 3, it's going to be negative. If I plug in a number bigger than 3, it's going to be positive. Velocity, there's 2, there's 4. We've already analyzed, so plus 0 minus 0 plus. So where is it speeding up? It's going to be speeding up where velocity and acceleration have the same sign. So that's going to be there because they're both negative, and here because they're both positive. Here they're opposite, here they're opposite. So the times are going to be between 2 and 3. And when t is greater than 4, because again, acceleration and velocity have the same time. Now we're going to find an expression for the position. So we're going to find the antiderivative of the velocity. So our velocity equation was 3t squared minus 18t plus 24. So we're going to take the antiderivative. So antiderivative of 3t squared is t cubed. This is going to be minus 9t squared plus 24t plus c. Because if I take this derivative, there could have been a constant. We're going to go back to our original information they told us, that x of 1 is 20, to figure out what that c value is. So we're plugging in 1. To find c. So 20 is equal to 1 minus 9 plus 24 gives us 16. So our c is 4, which means our position equation is t cubed minus 9t squared plus 24t plus 4. To find the total distance traveled from 1 to 3, always consider the velocity. Is it moving to the left? Is it moving to the right? Does it change? So from 1 to 3, from 0 to 2, it's moving to the right, and from 2 to 4, it's moving to the left. So it's moving to the right from 1 to 2, and it's moving to the left from 2 to 3. So I need to get the position at 1, I need to get the position at 2 where it changes direction, and I need to get the position at 3 because that's our stopping point. We'll take all of these and plug it into our position equation. If you do that, you're going to get 20 for 1. It moves right to 24, then it moves left to 22. Okay, so it goes right, stops at 24, turns back around and goes back to 22. So the distance here is 4. The distance here is 2, so it went 6 units in that time. Okay, here we have the position of a particle moving horizontal on a horizontal x-axis. Okay, so again, this is the position. So it says, is the particle moving right or left at time equals 0? So here's time equals 0. To determine if it's moving to the left or to the right, we're interested in velocity. So is velocity positive or is velocity negative? From a graph of position, I'm interested in the derivative, which means I want to know, is this graph increasing or decreasing? Okay, at t equals 0, the graph is going down, which means the slopes would be negative, which means the velocity is 0. Because s of t is decreasing, which means we are moving to the left. Okay, is acceleration positive or negative at time t? So acceleration is going to be the second derivative of position. How we're going to tell this on this graph, and we haven't really talked about this yet, but if the original graph is concave down, that means the second derivative is negative. And if it is concave up, the second derivative is positive. And vice versa. If the second derivative is positive, we have a concave up graph. If the second derivative is negative, our graph is concave down. For these problems where we have position, velocity, and acceleration, acceleration is the second derivative of this. So this graph, S of t, is concave down, which means this acceleration is negative. A of t is negative there because it's concave down. Okay, is the particle speeding up or slowing down at time 0? Well, we said that A of t is negative and V of t is negative, which means it's going to be speeding up. Because they're the same sign. And then is the particle speeding up or slowing down at t1? So we're going to do the same analysis. So first let's look at the velocity at t1. The velocity is going to be negative because it's decreasing, so the derivative there would be negative. The acceleration, that's going to be concave up, so my acceleration is going to be greater than 0, which means it's going to be, they're different signs. This one's positive, this one's negative, this one's positive, which means it's going to be slowing. So soon we'll be doing a lot of analysis of graphs as far as derivatives, but is the particle speeding up or slowing down? So we want to pay attention to what this graph is, and this is the graph of position. So speeding up or slowing down, we need to determine if velocity is positive and negative, and if acceleration is positive and negative. So this graph is increasing, which means velocity is positive. It's concave down, so it's increasing, but it's concave down, which means my acceleration is negative, which means it's going to be slowing. For this graph, this is the graph of velocity. So is it speeding up or slowing down? The velocity is positive because this is entirely above the x-axis. Every single velocity value on this graph is a positive number. Even though this is going down, this is the graph of velocity. For acceleration, in this case, we have the graph of velocity. Acceleration would be this one's derivative. So because this one is decreasing, the acceleration is negative. Velocity is positive, acceleration is negative, which means this one is also slowing. Like I said, we're going to spend a lot of time, not next unit, but the unit after that, dealing with the relationship between graphs and all of this stuff. The last problem on this page, the graphs represent position, velocity, and acceleration of a particle. Determine which is which. Well, just in general, if we take the derivatives, and this looks like a polynomial, 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 this looks like a degree 3 polynomial, this looks like a degree 2 polynomial, this would be a degree 1 polynomial. So the highest degree would be our position. followed by velocity, followed by acceleration, because when I take those derivatives, they would decrease in power. All right, we have a graph. A bug is crawling on a straight wire. The velocity of the bug from t equals 0 to t equals 11, or 0 to 11 is given. At what time does the bug change direction? So the bug is going to change direction when the velocity switches from positive to negative. So that's going to be at t equals 8. At what time is the speed the greatest? So speed is the absolute value of velocity. So our contenders are going to be any maximums or minimums. So here our velocity is 0, so our velocity is 3, so our speed is 3 here and here. Here our velocity is -4, which means my speed would be 4. So it's moving the greatest speed at t equals 10. And when is the bug moving at a constant speed? Well, that's when the velocity is staying the same. So that's going to be from 3 to 4 and from 6 to 7. Now we're going to graph acceleration, which is going to be the slopes of all of these individual lines. So we're going to graph the derivative. So we're going to look at the slopes. So from 0 to 2, we go up 3 over 2. So my slope is a constant 3/2 there. At these corners, it's not differentiable, so the derivative is going to have an open dot. Here we're going down 1 over 1, so it's going to a -1 between 2 and 3. From 3 to 4, it's 0 slope. 4 to 5, it goes up 1 and over 1, so +1. From 5 to 6, we go down 1 over 1. 6 to 7 is constant. From 7 all the way to 10, we go down from 2 to 4, so we go down 6 and we're going over 3. So that's going to be a -2 from 7 all the way to 10, and then from 10 to 11, up 1 over 1. So when does the bug speed up? It speeds up when both acceleration and velocity have the same sign. So here's my velocity, here's my acceleration. So my velocity is positive from here to here. So anytime between 0 and 8, my acceleration is also positive. We have it speeding up. So it's positive from 0 to 2. And it's positive from 4 to 5. Everything else, so right now I'm just caring about less than 8. This is all positive, those two are positive, anything else is not going to be the same. Then from 8 to 11, my velocity is negative, so anywhere where my acceleration is also negative between 8 and 11, then we're speeding up. So we're -8 to 11. Here we're negative from 8 to 10. So that'll be our last area where it is speeding up. These next two questions ask us for a velocity vector and a position vector. So all those are just breaking down x's and y's, but the derivatives are still going to be the same. So given the velocity vector of your particle, if our velocity, which would be the derivative, is x prime equals 4 cosine and y prime equals -2 sine t, find the acceleration vector at pi over 6. So we're going to take these derivatives and then evaluate them at pi over 6. So the derivative of x prime is going to be a -4 sine t. Y double prime is going to be 3 times 2, so -6 cosine 3t, using the chain rule. And if you have to do that in a couple steps, that's fine. Then I'm going to evaluate these at pi over 6. So that's going to be negative 4 sine pi over 6. Sine of pi over 6 is root 3 over root 3 over 2. No. Sine of pi over 6 is going to be 1/2 times negative 2, or negative 4 is negative 2. Y is going to be negative 6 times the cosine of 3 times pi over 6, which would be pi over 2. Cosine of pi over 2 is 0, the x value at the top of the circle. So this acceleration vector, and you can write it in different ways, but using vector notation would look like that. Next one's similar. We've got x and y, and we want to write the acceleration vector. So we're going to take two derivatives. So x prime is going to be 8t, x double prime is going to be 8. So this is multiple choice, so those ones are out. Y is the square root of t, so y prime is going to equal 1 over 2 root t. And it might make it easier to make this 1/2 t to the negative 1/2, since we have to take another derivative. So that's going to make it a negative 1/4 t to the negative, if I subtract 1, 3/2, which is going to equal negative 1 over 4t to the 3/2. And we're plugging in 4 here. So 1 over negative 4 times 4 to the 3/2. So this, when we have a fraction like this, this means we're cubing it and taking the square root. So I'm just going to take the square root, which would make it 2, then cube it. So 2 cubed is 8. So this is 1 over negative 4 times 8, which is 1 over negative 32, which makes our correct choice letter B. Thank you for your time.